We're learning to be tool safe.
Watch this video to find out the safety guidelines for this procedure.
In the open source or maker movement, we build electronic devices to do a huge variety of tasks, from robots to 3D printers to devices that talk and listen to the internet. Our electronic circuits and devices need power, usually in the order of 3.3 volts to 12 volts.
There is also a wide variety of sources of power, from USB ports to cell batteries to AA's and 9 volts, from solar cells to wall warts and switching power supplies connected to household 110-volt AC power.
Of course, when we are dealing with power of any sort, safety is a key concern. When we are dealing with high power, such as what comes out of a wall socket, it is vital that we respect electricity at all times.
In this project, we are going to adapt switching power supplies to power our Arduino circuitry, notably to provide power to Arduino ramps, 3D printers, or CNC machines.
Switching or switching mode power supplies are used most notably in desktop computers. They are a low-cost yet power-efficient type and widely available from older computers. You can also buy them from many sources.
These power supplies can supply 12 to 30 volts to power stepper motors, or 3.3 to 12 volts to electronic circuits. It's important to ensure you are not providing excessive power to your devices. Failure to do so could result in component meltdown or explosion and dangerous flash or shock to yourself.
We are going to use a purchase switching power supply that is designed to go with several positive 12-volt terminals with corresponding ground terminals marked as COM.
On the face of the terminal strip, we also see the terminals for the 110 AC power in, sometimes marked L, N, and ground. L stands for live power wire, N for neutral, and of course, ground is for the third ground prong on a 3-wire plug. Lastly, there's usually a terminal marked plus V, ADJ, which is a screw to adjust the power output.
Some power supplies come without a cover, others with a cover marked, "Do not remove this cover." This is a major clue for safety. Never power up an open power supply. There must always be a cover to protect yourself or others from severe shock.
Note that the terminal strip may be uncovered. This can also be hazardous, as a careless screwdriver or finger could easily cross over 2 terminals, serving the electricity to whatever crosses, again, causing severe shock or sparks. Never power up without a cover over the terminals.
We need to prepare a 3-prong plug for supplying power from the wall outlet. Your teacher will provide you with the plug wire or wire requiring a plug to be attached.
It is highly important to follow the color code convention. Note the 3 wires and their color. Black is the hot or live wire. It is the prong to the right in the wall socket. White is the neutral wire. That's the prong to the left, also the tallest prong in the socket. Green is the ground wire in the 3-prong plug. If you need to wire a plug, double-check your wiring and socket orientation over and over again. A mistake could be costly.
Next, we need to look at a way to turn the power on or off. We need to wire a switch into the power line. For this, we can use an SPST, or single pole, single throw rocker switch. We also need to add a fuse in line as well, if there is no fuse built in to the power supply. Depending on your application, you may also be mounting a mushroom emergency stop button. Instructions for these are found in the packaging.
First, we need to ensure our switch and fuse holder are rated for 110 volts or 115 voltage AC. This is written on the packaging and generally on the switch and fuse bodies. Using an underrated switch can result in melted or burning component.
We can't just hang the power switch in space. We need to mount the switch in a box or other device to keep the bare terminals hidden and to prevent the switch from being pulled out from the power supply or plug. You can use a plastic box made for electronics or create one yourself out of wood or even 3D print a box. Make sure you have somewhere to mount the switch and power supply together with the switch in easy reach of an operator.
So now is the time to plan for some PPE. You should be wearing safety glasses when handling small components and wiring and planning cuts of wire with wire cutters and strippers.
Also, make sure you're using the correct strength, right or left-handed metal shears or scissors for the job, so that you can do simple, clean cuts without struggling or forcing a cut on wire. When available, use actual wire cutters. Slipping can be costly and ruin a power supply or over-shorten a length if you're not in full control of your cuts and snips. Measure as needed and plan to pick up any wire cuttings for proper disposal. Make sure you plan to wash your hands after handling small wire pieces.
Okay, now back to the power. The switch is mounted in line with the live or black wire. Cut the wire at the switch location, stripping a short segment about 1/4 inch. Twist the strands tightly and either crimp on connectors or screw the wire into the terminal. Make sure you do not have excessive bare wire or loose strands that can bridge or contact other terminals.
Next, you will strip the ends of the plug wires to connect to your power supply. Like all connections, you must ensure you do not have excessive bare wire on the connector or loose connections that can bridge over or short circuit. Double check. Better to be safe than sorry.
Once you have the power connectors in place, you need to get approval from your teacher before testing your work and before hooking up to your device. Plug in the power plug to the wall socket, then stand back as you flip the power switch on. Be ready to unplug if there's a burning smell or the fuse blows. Make sure cooling fans are running properly.
Let the power run for a while. There may be some smell as shipping coatings are heated, but otherwise there should be no smoke or burning smell. If you smell something is wrong, disconnect from the power supply and check with your teacher. Do not cut into a wire to disconnect it.
Test your output connectors with the multimeter to see if you have steady power. Once you are sure everything is working well, then shut off power and unplug from the outlet. You are now ready to connect your device.
Every output connector must be checked for excessive bare wire or loose strands that can short circuit. Take your time and redo if needed.
Once everything is connected, you can test your device and its new power supply. Pay attention to smells and sounds. Test until you're satisfied. Pull on connections without power to ensure they are strong and will not pull free in use.
With practice and an eye towards safety, you can wire the creative machines of the maker revolution and ensure they work for a long time.
If you keep care of your equipment and tools, keep a neat workspace, and treat electricity with respect, you can avoid many of the potentials for accidents and injuries. Remember, there are no shortcuts. Take your time and do it well. Okay, time for a tool safe review.
Use proper PPE when doing wire cutting and handling of power. Always remove power before wiring any system. All components in a system need to be rated for the amount of power that will be present. All connections must be tight with minimal or no exposed bare wire. Double check and get approval before powering up any circuit. Clean up your workspace and return your tools to proper storage.
And if you're not sure about anything for safety, ask your teacher for more direction.
And don't forget to be tool safe.